Today we're looking for how many ordered pair positive integers. In the natural numbers, I'm taking it to be the positive integers. And there's something that's quite intriguing, which I've learned about fairly recently, is this thing called a prime signature. Now notice that P and Q are taken to be prime. And notice you have 2 and 1 here. Now we want to know how many ordered pair natural numbers solve this equation. It turns out there's a nice clean way to do this, but for those of you who haven't seen this, this is sometimes, I've heard it called the prime signature. Prime signature, that must be French. Okay. And you can make up any, this is called a multiset, and so you can do 5, 2, 1, 1. You can have repeats, that's why they call it a multiset. And however many numbers in there, integers, positive integers, even with repetition, gives you a natural number of a certain type, okay? So let's move along. Now, we'll state the obvious here. You can take the p squared out, of course, and rewrite our equation like this with a p in front of the square root of q. Okay. And y'all, as far as I know, I don't think P and Q have to be distinct primes. They can be the same 2 primes, I believe. And you'll probably agree with that once you see how this develops. All right, now we start with an arithmetic certainty, right? P is certainly equal to P minus I plus I, right? And this would hold for P minus 1 integers, okay? Now, so already you have a hint what's going on here. And you can just write down the candidate solutions here, folks. Since we're taking the square roots, you have to remove the radicals and square things. All right, and so these are the solutions, and I'll present that down here, and then we'll work a concrete example. Now, just in case you're not seeing, and this was quite a bit of discovery on my part, it didn't come near this easy when I was first looking at this problem. When you square root this, you get P minus I quantity times square root of q. Right? Then right here you get plus I times square root of q. See how simple, this is just rudimentary really, but I didn't notice it really until I spent quite a bit of time on this problem. But notice, what is that? That's just P times square root of q. Isn't that simple? And so if you trust, and I mean, you can just see it. It's dead on obvious once you notice it, but I didn't notice it that quickly, all right? And that's exactly what we have right here. Now let's work a concrete example just to make this a little simpler. What if we had, let's see, what is our problem again? Square root, yeah, square root of mn. And this is just a concrete example. In other words, this proves that there's P minus 1 solutions, by the way, folks. This statement right here proves that there are P minus 1 solutions. And I'm going to just find one solution for a concrete example. Okay, so there are P minus 1 solutions. Integer, positive integer, ordered pairs. All right, now, so let's see here. How about 3 times 49 is 147. So let's do the square root of, I'm doing 7, folks. I'm working with P equals 7 right here, okay? P equals 7 and Q equals 3. Okay, and so this would be the square root of 7 squared is 49, 3 times 49 is 147, right? Okay, so now let's take a look at a solution here. According to this result right here, one solution, your m, let's do m sub 2 maybe, okay? M sub 2. That would equal to 7 minus 2 quantity squared times 3, right? And this is 25, that's equal to 75. Okay. Now let's come down here and do n sub 2. Is just equal to 2 squared times 3, which is 12. And this is the one of the p minus, or the 7 minus, there would be 6 solutions, but this is 12. This is one of 6 solutions. You would have 7 minus 1 equals 6 solutions. Solutions abbreviated. So this is one of the 6, 75 and 12 would be a solution. You guys can verify right off, just plug in and you'll see that it does work. And so it's kind of cool that this depends only on the cardinality of P. Okay, the number of solutions depends only on the cardinality of P. The Q doesn't matter. All right, and this is just one concrete example. But let's come up and answer the question. How many? Well, there's P minus 1. Of these guys that satisfy the condition. All right. I think the stuff with prime signatures is fairly intriguing. Okay, thanks for viewing.